Hello student, hi, good evening. So today we are going to see the question number 74. Okay, so this is my question number 74. 74. So 74 is about if over the course of day, the maximum electron density in the ionosphere varies from 10 to the power 11 to 10 to the power 12 per meter cube. So this is ion density, that is n is given. Okay, ion density n, that varies from where to where, 10 to the power 11 to 10 to the power 12 per meter cube. So this is my ion density ion density ion density. Okay, this is my ion density that is given, and he's asking the critical frequency changes approximately. Critical frequency. Okay, so this is my critical frequency changes approximately. Critical frequency is how much it will change. Critical frequency change, as we know very well, for ionosphere the critical frequency is nothing but that is 9 square root of n maximum. This is the critical frequency in ionosphere. Where? Ionosphere. If you see this, n is equal to this 9 into square root of how much? 10 to the power 11 to 9 into 10 to the power 12. Okay, so this is what ion density. N maximum. So how much is this? Fc is equal to 9 into 10 to the power 11 means 10 to the power 5 into root 10 to how much? 9 into 10 to the power 6 hertz. Okay, so this is how much Fc is equal to 9 into root 10 is nothing but approximately 2.8. Yes, this is my 2.8 megahertz. Yes, 9 megahertz. So this is the critical frequency that changes approximately. Okay, so in ionosphere, as we know very well, in ionosphere the ion density is given this. Okay, and for that critical frequency, that will change approximately from 2.8 megahertz to 9 megahertz, and hence the answer for this is option C. Okay, so now see for next question, that is about so now see, next question is, what is the peak to average power ratio of signal? Peak to average power ratio of signal. Peak to average power. Peak to average power ratio of signal. Peak to average power ratio of signal, x of t is equal to a sine omega t with 50% duty cycle, with 50% duty cycle. Okay, so this is what peak to average power. What is the peak to average power ratio of the signal? With this of the signal, x of t is equal to a sine omega t. Now, if you see the peak value, if you see here, peak value is how much? Let's say peak value is nothing but a. Yes, a. So if you see the peak power, this is peak power. Peak power is nothing but what? Peak power is nothing but this is my peak amplitude. Okay, so this is peak amplitude is how much? That is peak power is nothing but peak amplitude divided by r. Peak amplitude divided by r. So this is my peak power. So this peak amplitude is how much given? A square by r. So a square by r. This is my peak power. Okay, and peak power and is given as and and is average power and average power is nothing but peak amplitude by root 2 whole square divided by r. So or you can say this is what ARMS. Yes, RMS or RMS. P average is equal to ARMS is equal to, so ARMS or you can say XRMS. Okay, RMS. So therefore this P average power is how much? This average power, peak power, this is average power is nothing but XRMS, which is nothing but XRMS is what? A by root 2. A by root 2 whole square divided by R power. So which is nothing but A square. A square by 2R. 2R. A square by 2R. So this is my average power. Average power. But he's asking for what? He's asking for duty cycle of 50%. 50% duty cycle. Duty cycle means here 50% duty cycle means this is T on. T on by T on plus T off plus T off. This is nothing but 50%. Half. Okay, half. So this is my, let's say here this is my input signal of what? 50%. This is my total time period. Okay, but it is on only for half period. So this is my T by 2. Okay, so this is my 50% cycle. So for this only up to this 50%. So that's why for this what? Peak average power. So average power is how much? Average power is nothing but half of. So this is my half of actual average power. Half of actual average power. Average power with 50%. Average power with 50% is nothing but half of average power with 100%, which is nothing but how much? A square. A square by 4R. A square by 4R. A square by 4R. So now see here. So therefore peak to what? Peak power to average power. Ratio is how much? How much is peak power? A square. A square by R. R. How much is average power? A square by 4R. A square by 4R is equal to 4. Okay, 4R is equal to 4R A square divided by A square into R. Okay, so this will get cancelled and this is what? 4. So therefore peak to average power is nothing but 4. So and in dB it is nothing but 10 log 4. How much is 10 log 4 is nothing but this is 4. So let's say this is 10 log 4 is, it is nothing but log 4 is 0.6. So 10.602 dB. So which is nothing but 6.02 dB. Okay, so and is approximately equal to 6 dB. 6 dB. And this peak to average power. Peak power to average power ratio is nothing but 6 dB. So therefore answer for this is about, this is D. D option is correct. Okay, so this is for peak to average power. Only we have to concentrate about this average power for what? For duty cycle of 50%. Means it is asking about only about 50% duty cycle. Okay, so this is my 100% duty cycle. Okay, so T on, T off, both. So but up to 50% duty cycle, we have to take what, half. Okay, half. Up to this it is on. So therefore it is half of this P average power. So that's all for today, and thank you very much. Okay, so